In this video, we will illustrate the solution of a simple problem involving kinematics. The problem statement is, a motorcyclist traveling at a speed of 32 meters per second on a flat road sees an obstacle ahead and hits the brakes. The motorcycle comes to a stop 5.2 seconds after the brakes are applied. The rate of acceleration is constant as the motorcycle slows down. And we are asked, what is the acceleration of the motorcycle and how far does the motorcycle travel while braking? We must remember that every kinematics problem involves some combination of 6 variables: the initial position of the object, the final position of the object, the initial velocity of the object, the final velocity of the object, the acceleration, and the time elapsed. So our task at first is to determine which of those pieces of information we're given. Step 1 is to read the problem and figure out what the problem is trying to tell you. Looking here at the problem, we see that the initial velocity is 32 meters per second. So we can fill in that part of the data table. We are then told the motorcycle comes to a stop. Now that's not an outright number, but it is a verbal clue that the final position of the motorcycle is going to be 0. And then last, we are told that the time elapsed during the braking process is 5.2 seconds. We're also told the rate of acceleration is constant. That's not in our data table, but it will be useful later on because it tells us that we can use the standard kinematics equations. Step 2 in this process is to figure out what the problem is asking for. Looking here at the first question, it is apparent that the question is asking for the acceleration of the motorcycle, so we indicate that in our data table. The second question is essentially asking us what is the displacement of the motorcycle. The term how far is our clue there. So we can make it easier on ourselves by setting the initial position of the motorcycle equal to 0. Therefore, we only need to find the final position to answer the question. And so we have figured out what the question is asking us for. Now, addressing the first question about the acceleration of the motorcycle, finding that acceleration will be a matter of finding the correct equation, the correct tool, to perform the computation. And step 3 in the process is to look and see which of the variables are irrelevant to our calculation, and that will guide us toward the proper equation. Looking here at our data table, we see we're given the 2 velocities and the elapsed time. We're asked for the acceleration, but in this first part, position is irrelevant. And one equation, the one kinematics equation for which position is irrelevant, is the very first one. V final equals V naught plus AT. Final velocity equals initial velocity plus acceleration times time. Looking at the data, we put in the data there, 0 for the final velocity, 32 for the initial velocity, and 5.2 for the elapsed time. Taking 32 over to the other side of the equation allows us to isolate A, and we get a value for the acceleration of negative 6.076 meters per second squared. Note that this is far too many significant figures for the problem since we only have 2 significant figures in our data, so we would report this as an acceleration of negative 6.1 meters per second squared. Also note the negative sign indicating that the direction of the acceleration is opposing the direction of the velocity. We assigned by default a positive sign to the velocity, so a negative sign by the acceleration indicates that the 2 vectors are in opposite directions. In other words, the motorcycle is slowing down. Looking to our second issue of finding the final position and therefore the displacement, we have 2 options here. We could utilize the second kinematics equation like so, because we know now every part of this equation. And so plugging in the values for initial position, initial velocity, time, and acceleration, we can figure out the final position. Note that the acceleration must have a negative sign. We must carry over that negative sign into this equation. We find that this gives us a final position for the motorcycle of 84.25 meters. We would report this as 84 meters to two significant figures. However, we could use the final kinematics equation to figure this out as well, although it is perhaps a little bit more algebraic effort. Once again, the final velocity is 0. The initial velocity, which we square there, is 32. And the acceleration, which is negative, remember, is negative 6.076. All right, when we work through this equation, we find that the final position is 84.27 meters. To two significant figures, this is 84 meters, essentially the same result as we got from using the previous equation, which is somewhat comforting. So we would report that the motorcycle has an acceleration of negative 6.1 meters per second squared, and it travels a total distance of 84 meters while braking.